have 3 blocks 30 kg, 10 kg, 10 kg which are being pulled in this direction with a force of 100 Newton. They are interconnected by 2 strings, this string number 1, this string number 2. Coefficient of friction between this horizontal surface and all these blocks is mu is 0.1. We are asked what are the tension in the strings and what are frictional forces. Suppose this is being asked. Whenever in cases like this, the first thing is you find the direction of friction force, that is which way the friction force direction will be. Direction of friction force can easily be found by if we can visualize, that is how the interlockings they are going to be there. If these are interlockings, that is these are irregularities at the lower surface and these are the irregularities onto the block at its lower face, then they are messed up like this. Now which is we are trying to move? We are trying to move the upper hand, that is we are trying to move the upper block. And when it applies a force in this direction, this gets in the backward direction, that is it experiences a force in this direction. So direction of frictional force, it applies a friction force in this direction and this experiences a friction force in this direction. Similarly, interlockings, they are here also. This tries to move it this way, so it pushes the earth in this direction, earth pushes it back in this direction, this pushes it earth in this direction, and this pushes it backward in this direction. So these are the direction of friction forces. Whenever we are trying to move one body over the other body, always first go to the direction of frictional force. Magnitude is a later kind of a thing, because there could be a case of self-adjustment, it may be accelerating, it may not be accelerating. The first step is always to find the direction of acceleration. So once the direction of friction force is established, then we go for the limiting value of friction force. Over here we see along the y-axis, if you see, that is this is 100 Newton is here, this is N1, normal reaction N1, similarly 100 Newton here, N2 here. If we just look at this one, that is because this block is not moving up and down, so downward force is 100 Newton, it has to be equal to normal reaction 1. Along the y-axis, acceleration is equal to 0, so that's why net force along the y-axis, it has to be equal to 0. So it means upward force, it has to equal to downward forces. Downward force is 100 Newton, upward force is N1, so N1 is equal to 100 Newton. So normal reaction over here is 100 Newton. So let's we now just bother about F1 only, that is the limiting value of friction force. Let's first find the values of limiting value of friction forces between the blocks and the surfaces, because from there we can say whether this will accelerate in this direction or not, and that will make the things much easier. So F1, the limiting value of friction force at this interface is mu into N. Mu is 0.1 into N is, we have just calculated 100 Newton, so that comes out to be 10 Newton. Similarly, this F2 is mu into N, that is this comes out to be 10 Newton. The value of this F2 comes out to mu into N, mu is 0.1, mass is same once again, so weight is same, so that will also come out to be 10 Newton. Over here the normal reaction will be 300 Newton, that's why F3 is going to be limiting value of friction force is going to be mu into N, mu is 0.1, 0.1 into 300, that is 30 Newton. So this is 30 Newton. Now if you look at what is happening along the x-axis, we observe that is 100 Newton is applied this way, which is trying to accelerate the system. And if we take this whole thing as one body, one free body as our system, then the tensions, they are going to be internal forces and they won't be considered, and the forces which are trying to stop it, these are the friction forces appearing at this surface, this surface, this surface, and their cumulative value is 10 plus 10 plus 30, that is 15 Newton. 15 Newton is the maximum value. This can be applied in this direction. Is this force capable enough to overcome their maximum value? Yes, it can, because that is 100 Newton. As a result, the net acceleration of this system is 100 minus 50 is 100 Newton minus this side forces is net force. It is equal to total mass 10 plus 10 plus 30, that is 50 into action. Net force is equal to mass into action. 100 minus 50, 50 is equal to 50 into A, so A comes out to be 1 meter per second square. So the value of acceleration, it comes out to be 1 meter per second square. If you wish to do the same question by simpler method, where we take the individual body or each block as a separate free body, from there also you can solve the question same way. That is, you see that there are 3 blocks. So what we do is we draw 3 circles. These 3 circles are drawn. Along the y-axis we don't have to bother much because the normal reaction we have calculated. From there we have found the limiting value of friction force also, and we have also seen that this force 100 Newton is capable enough to overcome the forces in the other direction, so it means the system will be accelerating. So our focus is primarily along the x-axis. If we say T1 here, so it is T1 here. Tension is in one string, there is one tension. Tension is always away from the body. We have done earlier in Newton's laws of motion. So this pulls it this way through the string, and this pulls it back through the string. To every action there is equal and opposite reaction, and action and reaction, they are on two different bodies. Now this is a different body, this is a different body. We are taking these three as a different free bodies. Had we taken this whole body as one body, then the tensions, they will become internal force. But now we are considering this body as separate body, this body as separate body. So through the string there is interaction, and we have to take that force of interaction into consideration. Now these are three coaches of the train which shall be moving with the same acceleration. They cannot have the different acceleration because the strings, they are inextensible. So whatsoever the acceleration of this, the same is acceleration of this, the same is acceleration of this. Now we have drawn the forces and we have separated the bodies, we have drawn the forces. Now the third step, F is equal to ma. So equation for this, if we say, that is, it is going to be 100, this side force, minus T plus 10. This side forces minus this side forces is equal to mass 10 into action. Net force is equal to mass into action. For this side forces minus this side forces. Now please don't shift this force over here. You can't shift. You have to focus your attention within the circle only. That is T1 minus T2 plus 10 is equal to 10A. And if you look onto this block, it is T2 minus 30 is equal to 30 into A. Now if you open the bracket, this bracket, so this become minus T1 and this will become minus 10. Similarly, when we open this bracket, this becomes minus T2 and this becomes minus 10. So from here we say, that is, when we add these three equations, minus T1 and plus T1, they will get cancelled. Minus T1 plus T1 is 0. Minus T2 plus T2 will get 0. So 100 minus, it is minus 10 minus 30. So it is, if you add it, 100 minus 50 is equal to 50 into A. So that is, A is equal to 1 meter per second square. You get the same thing. Then you can just put the values in these equations and can get the values of T1 and T2.